Okay, so for this question, you can title this like adding vectors non-right angled. Give me a blue. Come on. Okay, adding vectors non-right angled. Okay, come on, Mr. Line Over. Here we go. Did I switch the slide? This one, right? Okay, adding vectors non-right angled. If you look at the top left, they've given you the vectors. So the vectors are given here. These vectors are given up here. They're both the hypotenuse, both of these. The hypotenuse is the vector. But what are you talking about? Hypotenuse of what? There's no right angle. You have to create the right angles. So for vector 1, the 1.4 meters per second, 45 degrees north of west. Let's first look at that. Here's the 45 degrees. Why is it communicated north of west? Because that's exactly what's happening. The left side is west. Do you agree? And then the vector is north of that. You okay with this? And the 1.4 is just how much? How fast? And then the direction is 45. What you're going to want to do is, and I'd probably use a ruler for this, you have to draw the tail to tip components and then find those. So doing some trigonometry on that first triangle. Sine of 45 equals, I'll call this one y1, I'll call this one x1. Sine of 45 equals y1 over 1.4. Are you guys okay with that trig? Opposite over hypotenuse, this is good? People nod your head. Okay, awesome. Bring the 1.4 up. Make sure you're in which mode, especially if you wrote a test on Friday. It got reset to radian mode. Do it, follow along with me. Like, have your calculators out. Come on. Be typing with me. If you don't have a calculator, come up here and get one. I don't mind interruption. No, just get one. Make sure you're in the degree mode. Follow along with me. I don't want you guys just taking notes. I want you to be active. 1.4 sine 45. Hussein, just move it. Can you see the board from back there? Yeah, move a bit closer. I just want you on the side here. What do you notice about my answer there? I put 4 digits. That's for you guys. I don't even need that because I got this calculator, or better, you can go up and copy paste. If you're rocking the old one, make sure you're in degree mode. 1.4 sine 45. Well, check your mode. You put 48. If you have this one, you must go 4 decimal places, just to be careful on accuracy. If you got this one, go up and copy paste into the next answer, because we're going to be carrying forward our solutions to the next steps. Okay, let's go find x2. x2 should be the exact same. Why? Pardon me, x1. Why should x1 be the same as y1? Why is x1 the same as y1? Yeah, there is a right angle down in this corner, yeah. If that's 45, what does it make this? And then it's isosceles. So x1 is the same as y1. So 1.4, I'll just do it. x1 over 1.4. I'll do it in my calculator, even though I trust my math. Same thing. I'm being a little bit lazy for y1. For y1, I could put north. For x1, I could put west, but it's pretty much implied from the picture. That triangle's dealt with. Let's go deal with the second triangle. Where is the second triangle? No. It's where the other vector attaches to the tail to tip. So this spot here, that's the next vector that we're going to work with. Okay? So we got this guy and this guy. Using the 25. And what do you notice about that 25 degrees? Is it north of east? Is it? Here's east to the right, and then it's raised 25. You guys feel that? Okay. Also, look at the diagram. See how a dotted line was put in there? That was just there to help the diagram. How can I draw 25 north of east when I'm not at the origin? That's okay. If you're not at the origin, you're over here, you can still draw 25 degrees north of east. You might want to draw a horizontal to help you. All right, let's do some trig on this triangle. Call this one x2, call this one y2. Sine 25 will be y2 over 2.6. It follows that cos 25 is x2 over 2.6. We can get both of these quite easily. 2.6 sine 25. 1.0988. 2.6 cos 25. 2.3564. That's a 5. Okay. So that's just like how a mathematics class would treat two triangles. Now we have to enter the physics realm. The physics realm involves understanding of vectors, which entails direction. Now when you go to add these vectors, you have to think dimensionally. Can you add a y to an x? No. Can you add an x to an x? All right, so you have to be dimensionally consistent. X's go with x's, y's go with y's. And you also have to be in mind of direction. So x1, is x1 positive or negative for our reference system? Positives on the right, negatives on the left. So x1, when you go to combine that, you better give it a negative. How about y1? With our convention, up is positive and down is negative. So y1 is positive. Good. Now jump to the other side. x2 is positive and y2 is positive. All right, let's go here. Down somewhere where you got some space. I'll go x capital T, just for total, I guess. Keep it simple. X total. What is x total? Negative 0.9899 plus 2.3564. Somebody who's doing it with me confirm the answer. Yeah, confirm it, please. Good. 1.3664. Yeah, I got 5 as well in the end, but I didn't write it. I just used what my calculator says anyways. That 4th digit is just there for the calculator. We always round to 2 digits anyway, so it should be okay. Y total. These are both positive, so you're laughing. 0.9899 plus the 1.0988. I get like 2.088756 something. So, now visually, connect what you've done algebraically to what's happening visually. I'll use my pointer. Please, at this point, put your pencil down and just watch. You have a left and you have a right. Do those work against each other? For a sum total of 1.3664. Where can I put that 1.3664? Right there. Do you agree? Just think of it visually. Here's this big arrow, and I'm going to remove this arrow, so I'm left with this arrow. And which one dominated the fight? The east or the west? So, like, the east wins. By how much? This much. Good. Now, what about the two Y's? Do those guys work against each other? These two, do they work against each other or they work together? Yeah, because you have an up and another up, and altogether, those two ups, they make that one. The little y1 and the little y2 combine for the big y total. That's the 2.0887. And of course, these are components of a velocity vector. And now guess what you have to do? Your old buddy, Pythagoras. R is equal to the 1.3664 squared plus the 2.0887 squared. Are you guys okay with that Pythagoras shortcut? Also, like, if you have the newer calculator, it's so much better just like typing stuff in from a copy-paste perspective. It's just so much easier. Okay, I got two. How many sig digs we rocking here? Two sig digs. So my final sig digs is 2.5. Imre, you have a strong understanding of direction and magnitude. Can you tell me, am I done? I got my units. What am I missing, Mr. Imre? Good, the angle, the direction. So what do I have right now? I have the magnitude, and I still need the direction. The direction you can find with which feature? Sine, cos, or tan. I favor, which two do we find ourselves? The blue ones, right? So use those ones. You don't have to, but I suggest it. Op over adj, that would be inverse, the inverse of, I'll just write it out. What's tan theta, if this is theta in here? Tan theta would be op over adj. What is op? That's y total. Op, opposite. And what's the adjacent adj? X total. So theta will be the second function of tangent of those two, the y total and the x total. So that's like 2.0887 dividing this 1.3664. to two significant digits, what are we looking at? Okay, everybody get 57 on your calculator right now. Show me that you can do this. And am I done? Or have I just been lazy? What am I forgetting? 57 degrees where? North of east. Very nice. North of east. So in the boxes is what you're trying to communicate as your final answer. This, by far, gives students in Physics 20 the biggest headache. And it is the #1 skill you need for Physics 30. In the first unit of Physics 30, you have to be good at this. So I'll do another one, but at the end I'll let you guys practice before we do it again. I don't want to waste your time doing another one. We will do this one together, but for now I'll let you practice. I'll pause the video.